So today is the day that we kind of put all this together. Yesterday we looked at coefficients, right? These are the big numbers out front. That is a vocab word. You've probably been seeing it for a while. Remember, vocab quiz is going to be on Friday. Keep that in mind. We also said that we know these subscripts. Don't make it any harder or different. These subscripts have been part of the chemical formulas from the get-go, right? So those are not allowed to change. Just because we start balancing these chemical equations doesn't mean you completely throw out everything that you've already known, okay? You definitely need to keep the subscripts part of the formula. The only thing that we're adding in now are these coefficients that can go out front, because the law of conservation of matter says that what you have on one side, you have to have on the other. You can't create or destroy matter, so you can't just like randomly come up with something if it wasn't there to begin with, okay? What happens a lot though is that it changes form. So what you see is carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen, just rearranged. And so all you're doing is counting up, just like we did a bunch on those Kahoot questions, you're just adding up how many of each of those elements you have. And then you compare 1 and 1, 4 and 4, 4 and 4. So is this equation balanced the way it is? Is it balanced? Oh, it's yes. You have what you have on one side, you have on the other. If you're looking at the individual elements, not how they're arranged, but the individual elements themselves, right? The second thing is, if this is balanced, then it does satisfy the law of conservation of matter. You didn't create anything and you didn't destroy anything, right? You have one carbon here, there's still a carbon here. You have 4 hydrogens here, you have 4 over here. Right, so that's what it means by balanced. Even though this isn't an equal sign, this arrow is saying this creates or produces this. All right, so things just get shuffled and rearranged, but you're not changing. It's not like now you have an aluminum over here, or you have a nitrogen here, or you have a sulfur here that you don't have there, right? You have to have the same elements on each side, and you have to have the same number of each of those elements. That's the key. That's the whole reason why we have to do this balancing chemical equation stuff in the first place, right? Yesterday I also said, hey, you might want to put parentheses in. If you have a coefficient, putting parentheses will help you see that that 2 has to distribute to both elements in that compound, right? So as we go through these problems together, those are kind of the things that that are gonna stand out. Right, so looked at this on Friday. There's another way, and it was adding up the grams. So if you have 100 grams total of calcium bicarbonate, and then it's going to produce calcium oxide and carbon dioxide. So if you have a total of 100 here, you have to have a total of 100 over here. And so if you're given one of them, what can you do with these to find the missing amount of grams? What are we gonna do? What was that supposed to mean, Finn?
Minus.
Subtract. Yeah, that's what I was interpreting. But yeah, he was like, slash it, right? So 100 minus 56 will give you the missing amount of carbon dioxide, because those two have to total 100, right? So you can either do it with mass or you can do it by counting elements. We're going to be counting elements, and that we're going to pick up on slide. And one thing with the law of conservation of matter is that sometimes, and if you watch that, hopefully you watched that sugar water video on Friday, they had like 100 grams of water, and they had 50 grams, I think, of sugar, or maybe 25 grams of sugar. And it looked like the sugar disappeared when they put it together, but when they weighed it, it still had, it had those two total, right? So if it was 100 grams of water and 25 grams of sugar, that it combined to make 125 grams, even though it looked like the sugar disappeared. And sometimes that happens if something changes to a gas. You usually can't see the gas. So if you contain it and trap it, then the gas is in there and it's gonna still stay the 100 grams. So sometimes it seems like something disappears or is gone, but it's just because it's changed into a gas form and you don't see that. It's not as obvious if it stays a solid or stays a liquid. Okay, so this solid reacted when it's burned and changed into the gas. But you still always get whatever you start with, you end with. So this is where we're going to start on slide number 38. Okay, so it's going to kind of review some of this too. So you cannot just change that little subscript to make balancing the equation easier. That would be really nice if you could. But we know that that is part of the chemical formula and that is not allowed to change. So the subscript in a formula it is an identifying part of that compound. So if you change the subscript, you're changing the compound. Thank you. So, and I've given this example before. H2O we know is water. H2O2 is hydrogen peroxide. So it doesn't just make it more oxygen-y, it actually changes it and it's no longer water. So just that one little change of one extra oxygen gives you something totally different. Now, the way we handle this is coefficients. They can change. We put them in front of the compound. So it's changing the amount of the compound, not what the compound actually is. So here's my example, and I think I mentioned this yesterday. You can have 1 pepperoni pizza or 10 pepperoni pizzas. The 1 and the 10 are like the coefficient. The pepperoni pizza is like our compound. It's still pepperoni pizza no matter how many of them you have. It's just how many are there now, right? 1 or 10. Same thing with water. Like you could have 1 H2O or you could have 10 H2Os. It's still 10 of the same thing, right? So that's why we can put coefficients in, but we can't change the subscript. Subscripts are part of the compound, and that has to stay consistent. So in this example, it's still pepperoni pizza no matter how many you have of them. So no matter how many numbers you put in front, 1, 3, 5, 1,000,000, it's still pepperoni pizza. Just how many of them do you have? Okay. All right, so here's the process. Yesterday, what we did is we practiced identifying the elements involved. All right. Then we counted up how many of each one we have. So on your notes, off to the side, I have this chart. You're going to need to make sure that you are updating this chart as it updates on my screen. Okay? So you're going to be filling in, and notice we have the reactants because they're typically on the left-hand side. And so I put the reactants on the left-hand side of my little T-chart, and then the products are usually on the right. Now, it doesn't always have to be that way, but the examples we're going to look at, so that's why I kind of follow that order. Notice I kind of color-coded things even, right? So the reactants, I have this pink color, the products are in the green. So the first thing we do is we identify all the elements in the reaction, right? So, oops, what do you see here? What are in this reaction?
Calcium and nitrogen.
Yep, so C and N, or Ca and N, excuse me. All right, so the next thing is you're going to determine how many of each you have on each side of the equation. So when I'm saying each side of the equation, this is the reactant side of the equation, this is the product side, on each side of that arrow. So I'm going to put in, and this is where you're filling in, leave yourself some space because we might have to update this, so kind of go over to the left a little bit so you have a little bit of a gap and some room to work. So put Ca equals 1. So you're putting that on your chart. And then how many nitrogens are there? How many are there, Josie? 2. So we're going to put N equals 2. And then we go to, and we're just looking at the product side now, so we're gonna do CA. How many CAs are there? Cypress? 3, right? And then how many nitrogens, Xander?
2.
Okay, so we'll put N equals 2. So those are our totals, and that's just what we did yesterday in the Kahoot a lot. How many of those atoms do we have? Okay, so in your T-chart, make sure you write the elements and the total atoms for each element, and do that for the reactants and the products both. Now we're going to go to slide 40. Oh, in a minute. There we go. So, for a balanced equation, the number of CAs on the reactant side must be equal to the number of CAs on the product side. So, if I update my CAs, I have 1 and I have 3. Are those the same? No. So is this equation balanced the way it is? No. But let's check out the nitrogen too. We have a 2 and we have a 2. Is that one good? Yeah, so that's good, but we are going to have to do something because the calcium is off. So when the total number of atoms for each element are equal, that means that the law of conservation is satisfied. So it's good for the nitrogen, but it's not for the calcium, and that's our problem. So we need to fix that. So after looking at the chart, the way it's written, it is not satisfying the law of conservation of matter, and it is not balanced. So we have to fix that. Our only option to fix it is to use a coefficient to do that. We can't just go, oh, this needs to be a 3, and be like, boom, balanced. CA and CA3 are not the same thing. That would be changing what we're dealing with. So we just have to change the amount. So the only thing we can do is by putting a coefficient out front to make that happen. So on slide 41, the ends are equal. They each have 2 on, there's 2 on each side, so that's good. Okay, but the CAs are not. We have 1 and we have 3. So since we can't just change the subscript, our only option is to put coefficients in front of the side that is lower, in front of the element that is lower. So which one of these sides has the smaller calcium? Which one, Jack? The reactant or the products? Okay, so I'm going to have to build up the reactant side for the calcium. So in my mind, that tells me that's my only location. So you might want to draw that in. This is a kind of a good strategy. I know I'm going to put a coefficient. It's going to have to be in front of the calcium, and it's going to have to be on the reactant side. So you just told me the reactant side has only 1, not 3. So we have to put a coefficient in front of the CA on that reactant side, which is why I drew my line where I did. So coefficient in math means multiply. So we can apply that here. So what can I multiply by calcium's 1, because really that has a subscript of 1. So what can I multiply by 1 so that I equal my total of 3? Alexis? 3 would make sense, wouldn't it? So put a 3 in front of the calcium on the reactant side. Okay, so that's on slide 41. So you're doing this on your paper. Everything that I have, I think you have that equation. Yep. You have the equation kind of in the box. So make sure you put that 3 in there. Okay, so now, right, this was what I had underlined. We have to update our chart with our new total. So this is our new working equation, right? So what's this gonna, if we have a coefficient of 3 out front, we have to multiply it by the subscript of 1. So what's that gonna change my calcium total to? What do you think, Owen? 3, right? So any coefficients that you put in, you have to multiply through to the subscript, and that becomes our new total. So since the subscript is 1, the coefficient is 3 times subscript 1, and we get a new updated calcium total of 3. And so in the chart, cross out the 1 and put in the 3, which is why you needed to give yourself a little bit of space here. Okay? Cross out the 1 in calcium on the reactants and put in that 3. Make sure you have that in your chart. Make sure you have a 3 in that box for that working equation kind of on the right-hand side. All right, so now on slide 43, calcium has a total of 3 atoms on each side, and N has 2 atoms on each side. We didn't need to add any coefficients to the N on either side, so that nothing else needs updated. So this is your new balanced equation. This one is the original, it is not balanced. This is the updated one, and it is balanced. As long as you put that 3 in, you're good. Okay? So it's not that difficult, it's just a process. You just have to kind of keep working your way through those steps. Okay, and it's that 3 that makes all that possible. Okay, let's look at another one. So, we have barium and oxygen to make BaO. So let's identify the elements. So what do you see here in that equation? Just set them. Dorian, what do you see here? You can just tell me the abbreviations. Yeah, so we see barium and oxygen, though, and we see the same 2 things here. So we see Ba and O. Those are going to be our elements. Now we're just going to count up how many we have on each side. So Ba obviously is 1. How many oxygens are on the reactant side, Maddie?
2.
Okay, so we'll put O equals 2. Again, leaving some space right here. And then let's count up the product side. Ba, how many Bas are there? What do you think, Jacob?
3.
Where do you see a 3?
Wait, no.
How many Bas on the product?
I don't know.
How many Bas?
There's 1 BA.
Okay, that's the answer. Just make up random stuff. How many O's, Jacob?
There's 1
Okay. All right. So write those in. Ba equals 1, O equals 2, and then for the products, Ba equals 1 and O equals 2. Make sure that you're putting like the Ba's on the same line and the O's on the same line. It just gets confusing, like if you put the O up here and then the Ba on this side, because then like it's easy just to kind of look across. And if you have them switched, then it gets confusing. So kind of keep them lined up. Okay, so there's our totals. Chart is updated, hopefully. Now, we need to look at our totals. Let's look at the BAs. 1 on the reactant, 1 on the product. Is that good? Is it balanced? What do you think, Liam? 1 on each side.
Yes.
Yes, it is balanced. Let's go to the oxygen, right? 2 and 1. Is that one balanced, Allison? She's giving such a sad shake. No. Wow, wow, wow. Right? Not balanced. So if this is not balanced the way it's written, it does not satisfy the law of conservation of matter, and that's a problem. So what you have on this side has to total what you have on this side, and it doesn't. The BAs are fine, but the O's mess it up, okay? So when the total number of atoms for each element are equal, it means the law of conservation of matter is satisfied. But the way this equation right here is written, it is not satisfied and it is not balanced. So we have to fix it. So that takes us to slide 46. And so we know that the BAs are good. So hopefully we don't have to mess with those too much. But the oxygens are not. 2 and 1. We can't just change the subscript. We cannot do this. It'd be nice, but that doesn't work. All right? So we have to do coefficient. We have to put a coefficient in. That's the only way we can make this work. So ask yourself, which side has less oxygens? What do you think, Alyssa? Okay, the product side. So in my mind, I'm gonna have to build up the oxygen here. But you're like, wait a minute, all we need is the oxygen. But can I put something in between there? Am I allowed to do that? No, right? The BAO has to stay BAO. We can't just squeeze in a coefficient in front of the oxygen. Coefficients go out front, and this is one thing. Even though it's multiple elements, it is one new compound, and so we have to put it out front of the whole compound. So have a line in front, so that way it kind of keys you in that this is where we're going to have to put a coefficient to build up our oxygen. Put in that little horizontal line. We know that product side is low. So we have to build it up. So you ask yourself, since coefficients mean multiply, what can I multiply by 1 to get a 2? 2, right? So we have to put a 2 in front of the O on the product side. And since we need to put it in front of the O, our only option is it has to go in front of the whole compound, which puts it in front of the BA as well. Okay? So now we put in that 2. So make sure you have that equation in that little box on the right-hand side. Make sure you put in that 2 in front of the BAO on the product side. Right? And that takes us to slide 47. So why did I put a coefficient in front of the BA and not the O? Well, the BAO is one thing. It is a single compound, and you cannot separate it. Putting the 2 doesn't change the formula. It just, now we have 2 BAOs, or barium oxides, instead of 1. So, this is where we said, think of this as parentheses. Keep that mentally all together. And then just distribute. So we didn't have to distribute anything in our last example, but we do in this one. So we know really, we know this is a subscript of 1 and 1. So we're just gonna have to distribute that. Right, so as I go to slide number 48, I'm gonna actually do that. So any coefficient that you put in the equation, you have to multiply through to each of the subscripts in that compound. So the subscript for BA is 1. And so we have to update that in our chart. So 2 times the subscript of 1 is going to give us a 2. And we're going to have to update that in the product side. So we're going to cross off the 1. So on that chart, cross out the 1 and change that now to a 2. But we're not done. the 2 also has to distribute to the oxygen. Right? And so that's what we're going to do on slide 49. The 2 has to go to the 1 of oxygen, and so that's going to update it to a 2. And so we have to cross out the 1 again and update that one to a 2. Okay, is everybody with me so far? Again, you're just distributing this 2 to barium's 1, making that a 2. This 2 to oxygen's 1, and now that's a 2. Yes? All right, so that takes us to slide 50. So if I look at the chart, the oxygens are now good. And so one thing, I don't want you to erase the ones, cross them out with just a single line so you can kind of see where you started and where you came from. And then if there's any kind of an issue, it's easy to see, you know, like, but if you erase it, then it's harder to kind of follow your trail. All right, so make sure you're not erasing these, just cross them out instead. Okay, so looking at the chart, our O's are great, 2 and 2. They're balanced, but we screwed up our barium. So we have to fix that. So sometimes you fix one element and it messes up the other. And that's okay, it's not a big deal. We just have to repeat the process. We just have to kind of go back and reevaluate where we're at. So we're gonna just keep putting coefficients where they need to be until everything is balanced. So which side now has less BAs? What do you think? Okay, so the reactant side. So now the barium on the reactant side is low. So I'm going to put a line there. So that's where I know I'm going to put a coefficient. That's my only option to increase the BAs on the reactant side. So we're going to put a coefficient in front of the BA on the reactant side. And coefficients mean multiply. So I can ask myself, what can I multiply by 1 so that I get a 2? Again, it's going to be pretty simple math. What can I multiply by 1, Allison, to get a 2? 2. Okay. So we put a 2 in there. Okay. And from there, we're going to go to slide 51 to update our chart again. All right, so with the coefficient of 2 in there, let's update this. So the barium is really a subscript of 1. So a coefficient of 2 times the subscript of 1 is going to give you a total of how many bariums now on the reactant side? What do you think, Zariah? How many bariums are we going to end up with over here? Should be 2, right? So we're going to cross out the 1. Don't erase it, just cross it out, and then update it with the 2. You can't forget to update your chart, or sometimes people want to update the chart but they forget to actually write in the coefficient. I'm not grading or checking the chart. What I'm looking for is this. This is the new chemical equation that is balanced. So if you don't put the coefficients in, even though your chart shows that that's what you did, the equation is still not balanced. You have to actually make sure you put the coefficients in here and you've updated the chart there. Okay, so going to slide 52, let's look at the chart again, make sure we have everything even. So barium now has 2 atoms on each side, oxygen now has 2 on each side, and this is our new balanced and satisfied equation. So now the law of conservation of matter is satisfied with this equation. Over here at the top, it was not balanced. Down here, it is balanced, and it's good to go. So adding the coefficient of 2 in both places make that possible. Those two coefficients. This equation is now balanced, and it does satisfy the law. And that's what you do, right? You just identify elements, count how many you have, build up the smaller side until everything's equal. And you just keep going until everything is. Okay, so here's a few reminders. When you balance chemical equations, there is no real system. It's kind of trial and error. When you fix the totals for one element, like we did with the oxygen, it might end up messing the totals for the other, like it did the barium. And that's okay. Also, you cannot separate the BA from the O. You can't shove any subscripts, you can't shove any coefficients in between them. Only option is to work out front of that formula. So if you think of the BAO in parentheses, that's really helpful. And you're all familiar with the distributing property in math. And so it's the same general idea. Distribute that coefficient to every term or element in that compound. And again, you cannot just change subscripts. That changes the formula, and that's not okay. Those coefficients change the amount of the formula, but it does not change the formula itself. And also, make sure you don't just update that chart. Make sure you're actually writing in the coefficients, and vice versa. Don't just put in the coefficients and then don't update your chart, because if you don't update the chart, you can't see for sure that you're really done. Just like we might be like, okay, we're good with the oxygen, and you might not have realized that it messed up the barium. And so you have to have both of those new coefficients to make the equation balanced. Just having one of them leaves the barium unbalanced, and that's not okay. Okay? Any questions on that? So the next couple of days, we're going to be doing a lot of practice with this. Okay?